Okay, we will proceed to the detailed mechanical design for heat exchanger. Okay, heat exchanger is the common equipment that used in the chemical process plant. So these are the learning outcome in this chapter, which to evaluate the design calculation, sizing of major equipment of the design plant based on societal, health, safety, and economical aspect. So these are the schematic diagram of the heat exchanger. Usually the common type is the shell and tube. We have tube inside here, and this is the shell, the blue color one. Okay, the outline in this chapter covered as we're gonna start with the introduction, followed by basic design and theory. Detailed design, we may focus more on the shell and tube heat exchanger, including the type of shell and tube, the standard and code to design the shell and tube heat exchanger using TEMA, Tubular Exchanger Manufacturer Association. Okay, general design consideration, detailed design on the shell and tube, a lock mean temperature, which is the basic concept for any design of the heat exchanger, tube side heat transfer coefficient and its pressure drop, and also on the shell side for both heat transfer coefficient and also the pressure drop. Okay, as introduction, a heat exchanger can be defined as any device that transfers heat from one fluid to another. So the heat transfer is involved in the heat exchanger, whether we need to reduce or increase the temperature for the certain process. Okay, if we have counter flow here, we can see fluid B has opposite direction of counter flow to the fluid A. So maybe fluid B is the cooling medium, example, to cool the system. So fluid B, example, we use cooling water in the system to reduce the operating condition from maybe 80 to 50 degrees Celsius. So we require a cooling medium that maybe we have 20 to 30 degrees Celsius. So for the parallel flow, it has the same direction, both liquid for the fluid B and A. And this is if we have one shell for two passes here. If we have cross flow, which is the fluid B is cross to the fluid A in the tube and fluid B in the shell part. Okay, the heat exchanger can be categorized into a few types, such as we have double pipe exchanger, which is the simplest type used for cooling and heating. Shell and tube exchanger use most application apply this type of shell and tube exchanger. Okay, plate and frame exchanger, which is also known as plate heat exchanger, used for heating and cooling. We have plate feed exchangers, spiral heat exchanger, coolers and condenser. We have a direct contact. Usually, if we have a rapid cooling system, we use a direct contact, with whether in cooling or quenching. We have agitated vessel, usually involved in the reactor, and also fire heater. Okay, these are the example that I can capture in the from the industry. Okay, we have double pipe here and shell and tube. Okay, this is a shell and tube. Okay, this is the nozzle for shell and tube usually inside this shell. So we have maybe a long tube or depend on the type of tube. Somehow we can apply a U-tube heat exchanger. So we have a U-tube inside the shell. We have a plate frame, plate fin, and we have a spiral heat exchanger. So you can see a spiral on the tube inside shell and tube. And we have air cool, which is related to the cooler and condenser, direct contact, agitated vessel, and this is example on the fire heater. You can see we have a heat exchanger that we can have a fire and heater on this chart. chimney here. Okay, this is from the industry. You can see how big the heat exchanger is it. And then we have a series of the plate heat exchanger. So we have a series of the shell and tube heat exchanger in the industry. So basically in industry, they use the series of the heat exchanger to reduce the energy or power consumption for each shell and tube or heat exchanger unit compared the heavy one only. So it may tend to have a larger size that later maybe we have a difficulty in troubleshooting or perform the maintenance. So if we have a smaller size, so we can reduce the energy consumption and easy for the maintenance as well. Okay, the next we move to the basic design theory.